Hi, this is Algebra 1, Module 7, Lesson 2, the practice problems. So first of all, we're going to take the standard form of this quadratic equation, ax squared plus bx plus c, and just identify a, b, and c. So right now, we are going to start with a is 5, b is 3, and c is 6. A, b, and c. Okay. So let's go over here to this one. It's pretty straightforward. There's only one x squared, so a is 1. There is negative 7 x's, so we need to put a negative 7 in there. And there's a positive 3 c's. Okay, over here for number 3, we have negative 2 x squareds. And we have 3 x's, so b is 3. And it's really like a plus 0, so c is 0. Okay, down here for 4, we have 6 x squareds. I don't have any x's, so that's a 0 for the b, but I have a negative 5 for my c. All right, here looks like I have negative 3 a's for my x squareds. I have 4 x's. Again, if there isn't anything on the end, it's like a plus 0, so there's 0 c's. Over here, I have 8 x squareds. I have negative 5 x's. Keep that sign with the number. And I have negative 2 as my c. Okay, so here we need to multiply first and then identify a, b, and c. So when I do this, I'm going to run out of space really fast. I might actually do some of these a little bit lower. So number 7 down here is going to be x times x squared, and then x times a negative 4 is negative 4x. So that gives me 1 for A and negative 4 for B. And since there's no numbers on the end, that's 0 for C. Okay, 8. Let's do this one in purple. All right, so I'm going to multiply this one out. X times 2x is 2x squared. And then x times negative 1 is negative 1x. Then I'm going to take negative 1 times 2x, so negative 2x. Negative 1 times negative 1 is a positive 1. So notice, kind of makes a little bit of a smiley face in here. These are kind of the eyes, nose, and mouth. I've got to take and distribute each of these pieces to each of the other pieces. So when I combine these guys, then down here, 2x squared, negative 1 minus 2 is negative 3x plus 1. So that gives me 2, negative 3, and then 1. All right, go back to my blue. Okay, so 9 we'll do over here. So 9, I'm going to do these guys again. So 3 times 3 is 9. X times x is x squared. 3x times 2 is 6x's. Then I need to do the negative 2 times 3, which is negative 6x. Negative 2 times positive 2 is a negative 4. Combine these guys, 9x squared. 6 minus 6 is 0, so they actually cancel out, leaving me minus 4. So in this case, A is 9, B is 0, C is negative 4. All right, 10. If I can get room for this on the other side here. Okay, so 10 we'll put down below here. So again, I'm going to start my multiplication. X squared plus 6x, do another 6x in this case. 6 times 6 is 36. We'll combine these like terms. X squared plus 12x plus 36. So my A is 1, B is 12, C is 36. There we go. 11. Right here. So this time I'm actually going to just go ahead and put x minus 3 next to it. So that way I've got two of them there to be able to do my lines. So x times x squared, x times negative 3 is minus 3x. Negative 3 times x is another minus 3x. Negative 3 times negative 3 is a positive 9. Combine those guys. X squared minus 6x plus 9. A is 1. B is negative 6. C is 9. And 12. Once again, I'm going to x plus 5. Now the negative is on the outsides. Remember, we do exponents before we do negatives. So my answers will be negated by the end. Ah, what did I do? There we go. Okay, so let's write down 12 on here. So x times x squared. I'm just going to ignore this part right now. So I'm just going to forget that for the moment. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. Combine these guys. X squared plus 10x plus 25. Now I need negative for the whole thing, which means I'm going to distribute this to each number, which results in negative x squared minus 10x minus 25. So A is now negative 1, B is negative 10, C is negative 25. So that's how you do that when you've got negatives in there. All right, let's keep going. So for this guy, graphing the standard y equals x squared parabola, include at least 3 accurate points on each side of the axes, state the vertex, and we're going to complete the table. Okay, so the vertex is going to be 0, 0, right? Because we know that with our x squared, if I put negative 3 in there, negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So when I go to graph this, let's go ahead and put our line in here. It's kind of a darker one. Let's match with him. And then we'll go ahead and put this one down the middle-ish. Okay, so we'll do it in purple. So we've got 0, 0, 1, and negative 1 are 1. 2 is 4, so it's negative 2. 3 is 9, so 4, 5, 6, 7, 8, 9. Okay, so graphing my parabola there. So now we're going to write the transformation in vertex form. Find the value for w such that the graph will have a specified number of x-intercepts. So let's mark over there. We are going to have, let's see, so if I need 2 x-intercepts, that means I need to move this down so that my parabola will cross the x-axis. So if I move it down, then I can have w equal, we can say negative 3. Mostly, w just has to be less than 0, right? So it moves down. For this one, I needed to have 1 x-intercept. Well, right now it has 1 x-intercept, and I haven't added anything to it. So w has to equal 0 for that. For it to have no x-intercepts, it has to move up on the line, right? It has to go so it doesn't even touch the x-axis, which means w can equal anything that's positive. W has to be greater than 0. So we can say it's 4 because that would work. So now let's look if we put a negative x squared. So remember what the negative does. The negative turns that graph so it's upside down, right? But it's actually, let me erase that line. It's actually touching the x-axis with negative x squared. So if I want 2 x-intercepts this time, I need this to move up so that when it's facing, when it's tipped over like this, it crosses the x-axis. So here we'll say w equals 8. And what we really mean, scoot this up just a tad, is that w has to be greater than 0 to make it have two x-intercepts. If I just want one x-intercept, pretty similar to the last one, it's got to be touching right on that with 1 point. So w will have to equal 0. If I want no x-intercepts, this time I need to move it down so that when it's curving downward, it's not hitting the x-axis. So we'll just say w equals -5. What we really mean is w has to be less than 0. So any number less than 0 would work for that. Okay, so now let's graph the following equations and state the vertex. So x minus 1 squared. So if you remember, anything inside the parentheses moves it right or left. So I subtract my x coordinate of my vertex. Well, my x coordinate would be a positive 1 because I'm subtracting 1. And so then if I do 2 minus 1 is 1 squared, each thing on each side of it. If I do 3 minus 1, that's 2 squared, which is 4. 4. And then I don't know if I have room to do 3 squared. Oh, just enough room. Just enough room. Okay. So my vertex, oh, you know what? We're just going to write it. Vertex is 1, comma 0. Okay. So this time I'm actually going to write my vertex first because I can look at my equation and figure out my vertex. So here I'm subtracting 1. So 1 is my x coordinate, and I'm adding 1 on the end. So 1 is my y coordinate. So if I go to 1, comma 1, that should be my vertex. And so I'm going to go to 2. 2 minus 1 is 1 squared. 1 plus 1 is 2. So I'm going to do 2 on this one. 3 minus 1 is 2. 2 squared is 4. 4 plus 1 is 5. So 1, 2, 3, 4, 5. This one's also going to be 5 since that's my vertex. And I'm going to stop there because I know I can't get a whole lot higher. Last one. Vertex is, well, I'm subtracting my vertex, my x coordinates, so it's a positive 1, comma, I'm adding 1, so it's a 1. So it's 1, 1 again. But this time we put a multiplier on it. So when I put in my 2, 2 minus 1 is 1. 1 squared is 1. 1 times 2 is 2. 2 plus 1 is 3. So it's going to be a little steeper this time, a little skinnier. 2 minus 1 is, sorry, 3. We're at 3. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. So I think that's the very top one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right up here on the top. And I have made my parabola. Nice job. And last page. A couple more of these. All right, so here I subtract my x coordinate, so that must be a -3, -3. I'm not adding anything, so it's 0. So I'm going to go to negative, oh, -3, 0. I did it backwards. -3, 0. And so if I go to -2 plus 3, that's a positive 1 squared is 1. And -1 plus 3 is 2. 2 squared is 4. So then I've got 4. 0 is 3 squared, which is 9. 4, 5, 6, 7, 8. Consistent with how many boxes they do today. 9 boxes on all these. There we go. So here the vertex is -3, because I'm subtracting. And then I'm subtracting 4, so it's -4. Okay, so -3, 1, 2, 3, 4. Should be this guy right here. So now I'm going to do -2 plus 3 is 1. 1 squared is 1. -1 minus 4 is -5. So I'm actually going down this time, which we've got this on here. This should give us the hint it's going, this vertex is a maximum. So 1 plus 3 is 2. 2 squared is 4. -4 minus 4 is -8, which should be the one right before. There we go. Okay, that's all we have room for on that guy. So for here, we're subtracting our x, so it'd be subtracting a -1, and we're adding 4, so that's our y. So -1, 1, 2, 3, 4, and let's do 0. 0 plus 1 is 0. 1 squared, oh, you know what? Let's not do 0 because let's do numbers that'll get us an even number on here to take half of it. So let's do 1. 1 plus 1 is 2. 2 squared is 4. Half of 4 is 2. -2 plus 4 is +2. So our next one is bumping over 2. So if I go to 3 next, yeah, 3 plus 1 is 4. 4 plus 4 squared is 16. Half of 16 is 8. -8 plus 4 is -4. So 4, 1, 2, 3, 4. 1, 2, 3, 4. Right? 1, 2, 3. Yeah. All right. So again, we know there's a negative in the front. So we have our vertex like, oh, you know what I didn't do? I need to erase this line because I did not put my dot over far enough. When you skip by twos, you got to make sure you skip by twos on both sides. There we go. I thought that looked a little uneven. All right. And the last ones. Use the table to identify the vertex, the equation for the axis of symmetry, and state the number of intercepts the parabola will have, if any. State whether the vertex will be a minimum or a maximum. Okay, so vertex. Let's look for repeats. Here's a repeat. Here's a repeat. That means that's my vertex. 0, -6. So my axis of symmetry is x equals 0. X-intercepts looks like it's going to be, so 0, -6, -5, -2 looks like it's going to go up this way. 2 x-intercepts, and that makes this a minimum. All right, for here, looking for my repeats. So my vertex is 2, 1. Axis of symmetry matches that vertex x. So here, looks like I'm only doing positive numbers. So if I look at it, it's 2, 1, and then I go up to 4 and keep going up, which means I would have no x-intercepts, and that's still a minimum. Okay, so for this guy, here is my vertex, -5, 7. So my x equals -5. X-intercepts, it looks like I have positives and negatives over here, so I probably will have 2, but to figure out if it's a maximum or minimum, -5, 7 is going to be up here. Then I'm going to go down to 3, and then -9. So it looks like it's going this way, which means it would be a maximum. And the big finale, oh, I only see one repeat, but it's enough to show that my vertex is -7, -8. So my axis of symmetry is x equals -7. They all look negative, so I'm going to say 0. But again, let's check this out. -7, -8 would be something like this. And then I'm going to -9 and 12. So I'm clear over here. So that looks like we've got a maximum on there. And that should be it for this lesson. Thanks for joining us. We'll see you again next time.